Okay, chemistry guys. Hope everyone's safe and doing well. This is what we're going to be up to. So we're going to do lessons and material here on video, and then I'll post it through a YouTube link. And from there, so I'd like you to watch the video. I'll also put the notes on our Google Classroom as we always have, but I'll try and kind of teach to those notes or go over them here on my whiteboard that I've got. And then there'll be some questions there that you can practice, and then any questions you might have, the Google Hangout that I included, feel free to just post questions there, and if it's a question I think everybody could use the answer to, then maybe I'll just build it into a video. If it's something individual for you, then I will just respond on either just to you, or if I think I can respond adequately typing it, then I'll just put it on the Hangout as well. So that's how we're going to go about it, and we'll kind of see how things work. And if you know someone who hasn't checked in yet, if you could just remind them to check in. I think it's Mackenzie and Olivia, and there's one more who hasn't checked in. I'd have to look it up. But if you know those people and you know they haven't checked in and know they can get these, please have them do so. So let's just get at kind of some review that we did before we left. In here on our trusty whiteboard. So we talked about different reactions, and we had done a lot of balancing of equations and stuff. So we're going to start to have to identify what type of reaction it is as well, along with balancing. So we said that synthesis is A plus B, two or more things coming together to form a new compound. So there can be more. The book will show you some examples. We could have A plus C plus B plus D to give us A, B, C, D. That's possible too. Same way that in decomposition, we could have a really large compound, and I think the book gives us one in decomposition reactions where it is, there it is, it's TNT. So when they have an explosion, the reactant is C7H5 bracket NO2 bracket 3, so quite a large one. It breaks down into C, CO, N2, and H2O. So quite a few reactants sometimes. We can break it into several parts. So decomposition a little bit tricky trying to predict the product sometimes. So with these ones, what we talked about is that a lot of times when we get some products, we do some tests on them to see if it's CO2, whether lime water turns milky, or we do the popping test for hydrogen gas, or the glowing splint to flaming splint test for oxygen gas, those type of things. We ended up with single displacement as our last one, where we said that if we have a metal and then a solution with a metallic compound, with an ionic compound in solution, that we could have the metal displace the metallic cation from that compound and take its place and liberate that particular metal on its own. So we'll see some examples in just a second. That's why when we did our lab, we saw some reactions happen quickly and some reactions not so much. And so we'll talk about that in a second. The thing I don't know if we talked about is that rarely, but there's the occasional time where we see it, where we have, when A and C in this case, so A and C, when we're talking about halogens, so whether it's fluorine or iodine or chlorine, if those are both halogens, they have their own little series where this particular halogen can displace this one and end up, and the reason it's Ba is because this is a halogen, so this could be sodium chloride, for example. Remember, sodium always, the metal always comes first. So if this was like fluorine plus sodium iodide, then we would get the sodium now joined with the fluorine, and the iodide would get liberated. So that's just when they're both halogens. Okay, so those are the general form. If we start to talk a little bit more, I guess specific, some things we talked about, we saw that sometimes when you did your single displacements in the lab the last day we were in class, sometimes you put copper metal into the four other solutions we had, and some of them worked and had a reaction, and some of them did not. And that's all due to the activity series of metals. So the activity series, as we talked about, is a list of metals. Let me find it here. So I think the ones we had, for example, we had calcium in that lab, and we had sodium, and we had magnesium, and we had zinc, and I think iron, and maybe copper. All right, so if this is our activity series of metals, what we're saying is that this is the, as we go up, this is most reactive to least. And there are more in there, but we're just including kind of ones we did in the lab. So what that is telling us is that the higher up, so in our general example where A plus BC produces, right, we want to bump out that B and it gives us AC plus B. So one, this metal by itself takes the place of the metal in the compound. So what we see here is that if we add, the higher up you are, so if A is higher up in the series than B, then this reaction happens. But if A is lower, so for example, if we added calcium to magnesium sulfate, okay, so let me do that little reaction right here. So if I added calcium plus magnesium sulfate, I look at my thing, my series, calcium is higher than magnesium. So this reaction is going to happen. Magnesium is going to get bumped out, it's going to be by itself. And calcium is going to join with sulfate. And this is where our nomenclature stays in play. Ca, we have to do calcium sulfate, which is Ca plus 2 and SO4 negative 2. And if we cross them over, we would end up with CaSO4. Right? This equation is already balanced. So that's one single displacement that would happen because calcium is higher than magnesium. Okay. Now, let's say we had we added copper metal to zinc nitrate. Remember, zinc plus 2, NO3 is negative 1, crossover. Right? When we look at this, copper is here, it is below zinc, which means if it's below, then we're going to have no reaction. Nothing's going to happen. I remember some of you asking me during that lab, well, what happens? Why isn't it working? Why isn't it working? Well, because it's below it and it's unable to displace that metal, so we don't get a reaction. So that is going to happen sometimes. So we consult the activity series. Just one that we have to make sure we watch just for products. So if we take magnesium plus iron 3 nitrate, right? Magnesium above iron, so we are going to get a reaction. So we know that iron now is going to be by itself, freed. And magnesium is going to join with the nitrate. Now magnesium is just a plus 2 charge, so it's MgNO3 2. Now the thing we have to consider when you're doing these reactions and write them down is that now we have to balance it. Well, here we have 3 nitrates and here we only have 2. So hopefully you realize the best way to do it is if I put a 3 there, that gives me 6 nitrates. Put a 2 there, that gives me 6 nitrates. Now I have 3 magnesiums, which I can put there, and I have 2 irons, which I can put there to balance that equation off. Okay, again, you can, whenever you get one, count on if you've got a difference and go about your balancing the way we always have. Okay, so it's important that we can differentiate between those, which one, when a reaction is going to happen, when it's not. The other thing, and we saw a little bit of it in our lab as well, is that if you add calcium to the copper solution, because it's quite a ways away from it, that's going to happen pretty quickly and pretty vigorously. As opposed to if you put iron and copper, that doesn't really happen as quick. It takes a little bit longer. So that's why some of them you had to wait a little bit in our lab to get the reaction. So that's the reason. I know this seems kind of fast, but I've got 3 classes, so I've got a little bit limited space for you guys in terms of the amount of space I have to talk about all this stuff. So let's jump now into, I'm just looking for my note page that of course I seem to have misplaced. So I'm going to leave you, I'm going to go to double displacement reactions. Okay, double displacement. So we have, I think we reviewed this, but I can't remember for sure. AB and CD. Now both of these are ionic solutions. So we took ionic compounds and dissolved them in the solution and put them there. And if this is what's going to happen, then we're going to get A, so the metal of one side joins with the nonmetal of the other, which is AD. And this is the important part. You have to put the metal first. That's C, and the nonmetal is the second part. Okay, CB. So what we're going to learn in this section is we're going to determine, can we see the reaction? Because if everything stays in solution, if this is solution, if this is AQ and this is AQ, which they always will be, and this is AQ, and this is AQ, then you put two clear solutions together and you still have a clear mixture of solutions. You can't really tell if anything happened. Okay, so what we're going to do with that is we're going to look at one way to tell if something happened would be, do we produce something that we can see? And hopefully you guys can realize that one of the things that we could see, sorry, my writing is not great. One of the things we can see is if a precipitate forms, and a precipitate is a solid formed when two aqueous solutions are mixed. Okay, so you take two clear solutions or slightly colored solutions like we did in our lab, and you get a solid that forms. When you put the two liquids together and a solid forms, you know you've got a precipitate, so we know we did a double displacement reaction. The other one, similar to a precipitate, if you've got gas bubbles, so I guess it's to the above. I guess I didn't need to write that, but a precipitate's a solid that forms. So if you see gas bubbles forming from the two liquids you put together, that's a possibility as well. And if that's the case, then yeah, you've had a double displacement reaction as well. So let's look at how we're going to find that. And there is a chart on page 173 of your book. And it says, it's got, I'll just replicate it a little bit. So we've got very soluble, and we've got slightly soluble. So if we take, we do this. Sorry guys, it's taking a little bit of time here. I'll just put a couple examples. That's a popular one, SO4, -2, Ca plus 2, Ba plus 2. So hopefully everything's going well for you guys, but so I'll just leave those two, and then these ones down here, let's put CO3, -2. Okay, let's just do it this way. Okay, so this is what our chart looks like, and it's in your book. Again, it's page 173. So it's starting with soluble. So what's going to happen is that if we have, it's going to be, if it's very soluble, it means when we combine that AB plus CD and we get AD on the other side. To decide the state of matter, to decide are we going to get a precipitate, we can find out, because like I said, if they both are AQ, then we're not going to get any precipitate, we're not going to get any gas, we're not really going to see any reaction. So when we have this solubility chart, when things are very soluble, that means they're going to be AQ as products. So for example, any product that comes out as a nitrate, every single nitrate is soluble. Okay? Every single nitrate is soluble. So there are no exceptions to that. As opposed to, say, sulfate. Sulfate is going to be soluble. It's going to be AQ with most. In your chart, you'll see there's a few other exceptions. But if it's calcium sulfate, that's going to be a solid. If it's barium sulfate, that's going to be a solid. If it's lead 2 sulfate, that's going to be a solid. If it's lead 4 sulfate, that's not one of the exceptions. So lead 4 sulfate would be very soluble. These are the exceptions. Lead 2 sulfate, insoluble, would be a solid on the other side as a product, as opposed to lead 2, which would be AQ. I'll do some examples of the exactly the actual reactions in a second. Where now the other side, also slightly soluble, so you go down and your ions will all be here. The other ions in this chart are Cl negative and other halides. That's all the halogens, iodide, fluoride, chloride, all those ones that are in there. We've also got acetate, we've got sodium, we've got potassium, all those in there. So at the bottom here, a few other common polyatomics. The carbonate is basically insoluble. So slightly soluble means it doesn't really dissolve. So you're going to get a precipitate every time you use a carbonate, unless it's a carbonate with any group 1. So if it's lithium carbonate or sodium carbonate or potassium carbonate, those are an exception. Or in this case, ammonium carbonate. Any of the group 1s or ammonium that join with carbonate are going to be exceptions, which means they're the opposite. So these exceptions were insoluble. These exceptions are going to be more soluble. So that means sodium carbonate, soluble, magnesium carbonate, magnesium's from group 2, insoluble. Okay, so that's how you use that chart. You're going to do a lot of that when you're how to predict. So I'm going to do a couple reactions here. And again, these are in the notes, but I'll just write the reaction and then show you how to predict. Sorry, I have to erase it. I've got a fairly small whiteboard. KCl plus AgNO3. Okay, so the first thing we're going to do, AQ. And states of matter are important. We've got to start putting them in. Every time we're at a chemical reaction now, we should have our states of matter. So we know that we're going to take the metallic part of one with the non-metal part of the other. So this is where you have to do your nomenclature. KNO3, remember K is plus 1, NO3 is negative 1, so that's going to give you KNO3. I'll leave that and I'll put the next product here. And then silver is plus 1. Chloride is plus 1, so that's going to give us AgCl. You flip back to your chart. So the first thing I'm going to look for is, okay, my ion here is nitrate. Nitrates are very soluble. Check for exceptions. Are there any? No, there are no exceptions, which means that's very soluble, so that's AQ. Next one, I've got the chloride. Chloride is very soluble, except, so it's very soluble, but there are exceptions. Unlike nitrate, which has no exceptions, chloride has a couple. Exceptions for chloride and the other halogens, copper 1, silver, silver, that's what I have. I have silver, which means that's not going to be AQ, that's going to be solid. That solid is your precipitate. So if you take this and this, KCl, potassium chloride, and silver nitrate, those are clear liquids in solution. You pour those together, you will almost instantly see a chunky, solid substance falling out of solution and sitting at the bottom of your test tube. That is your precipitate. That is silver chloride that you've produced. Okay, so that's double displacements producing precipitates. Now, again, if it produces a gas, same thing, you'll see the bubbles. They're a little harder to predict, so you might see a couple of them in our practice questions, but we'll go from there. I'll do one more and show you how to write it when we get a different circumstance. So if we have K2SO4 AQ plus FeCl3. So when you do these, hopefully you should practice some naming K2SO4 potassium sulfate, FeCl3. I know it's probably been a while since you've done them. Remember, multivalent, so iron 3 chloride. All right, so I'm going to take my potassium, I'm going to put it with my chlorine. So that's going to give me KCl. I'll leave my state of matter there, and I'll wait. Then I'm going to have Fe, and I know it's Fe3 because that's what it was here. Fe3 combined with SO4, so I'm remind you of the crossover. SO4 negative 2, cross down, can give me Fe2 SO4 3. That's my other product. Fe2 SO4 3. Okay, now in those, once I have those, you should go back and balance right away. Right? Remember, always start with your polyatomics. I got 3 sulfates there. Here I've only got 1. Okay, so once I balance that, right, in this particular one, now I've got my potassium. Right here I've got 6, which means I got to put 6 there. Now for my chlorines, I've got 6 chlorines here. I've only got 2 irons, 2 irons. So I'm good. Okay, but let's go back to worrying about the state of matter, because that's really the crux here that we're doing. That's kind of a little review lesson. Again, my ion I'm looking at is my chloride. So I go back. Only exceptions are copper 1, no. Silver, no. Mercury, no. And lead 2, no. So there's none. That's not an exception. And they're highly soluble, so that's AQ. Okay, now this one is a sulfate. And sulfate, and this is why our nomenclature, like I said, is so important, because you have to know, what is this you're combining? Is it Fe2? Is it Fe3? Whatever. So we got to go into that chart. So sulfate, very soluble, so it could be AQ, and it is AQ unless it's with calcium, no, barium, no, strontium, no, mercury, no, lead 2, no, and silver, no. So that is also AQ, okay? Because aqueous solution and aqueous solution get mixed and they turn into aqueous solutions. Basically what I'm seeing here, we won't see a precipitate. Okay, we're not going to see a precipitate here. So because you got no precipitate. So we can't really see anything. So we can't say for sure that this actually happened because we can't see it with the means that we have. Okay, hopefully that makes sense. I'm going to leave it there as a first kind of day. I'm going to post this video. So again, I'm going to post the video for you. I'm going to post the notes from double displacement, same way we have in our classroom. The practice questions are in there. Any question you have or that you would like the answer to, some of them that I might do on a video. If it's popular with a lot, I'll just put it on a video and go through them at the beginning of the next lesson. Some of them I may just be able to respond, like I said. But on the Hangout, post your questions there, and anything that's not one of those, then you can, actually no, any questions, sorry. And like I said, I'm still new to this. Any question you have, put it there, and I will answer it either through there or through a video. Okay? If you guys could put the questions by, any question you have by Thursday at 3 p.m., that way I can go through them and either answer or put the new video up on Friday. So I'm anticipating putting a new video up from chapter 5, which is pretty short. It's only a couple sections, but I'll put some up there on Friday. Okay, guys, stay healthy, stay inside, and hope we're going to do this for a while, but hopefully I'll see you in May.